Okay, so this says here y varies inversely as x and y is equal to 3 when x is equal to 8. Okay, now it also says write and graph the inverse variation function. Now we just talked about direct variation. Now we're going to talk about inverse variation. So what is our inverse variation formula? Well, it's y is equal to k over x. Okay, so y is equal to the constant of variation divided by x. Well, what do we do with this information here? We want to find what our k is equal to, our constant of variation. Well, we know what y is equal to and we know what x is equal to. So why not substitute this and we can solve for k? Right? We can do that, correct? Well, look here. This will be y is equal to 3. So it'll be 3 is equal to k over x. What is x? 8. Then if we solve for k in this equation, we multiply by 8 on both sides. These will cancel, leaving me with k is equal to 3 times 8, which will be k is equal to 24. Okay? Perfect. So in order to write the direct variation function, equation, all we have to do is just substitute k for k. And they'll have it, because this is enough information to tell me the relationship between x and y when x is equal to a number and also when y is equal to a number. So this will look like this. Y is equal to 24 over x. Okay? So this is the variation function here. All right. Now it says, now that we've written the inverse variation function, let's go ahead and see what its graph will look like. Well, in order to do its graph, let's go ahead and make a table of values, because this function here is undefined at point x is equal to 0. Okay, so you never want x to equal 0. So x should not equal 0 because it's undefined at this point. Because if we put a 0 as x, we get 24 divided by 0, and this is division by 0, which is said to be undefined. So we want to make a limitation on that, just as a side note, so when we get into talking about rational functions here, we know that there can never be a 0 in the denominator. You know, the denominator can never be equal to 0. Okay? Now, let's look here. So let's go ahead and make a table of values, okay? Let's see here for a second. Yeah, let's go ahead and make a table so that we can get stuff on both sides of our graph. Let's do a table that has negative values, and let's also do a table that has positive values. So we're looking at x and y. Okay. Well, let's go ahead and find x first. Let's get some values of x. For x, we're going to say a -3, a -4, a -8. Let's do a -12. Okay, when x is equal to a -3, what is y equal to? Well, if we look here, y is equal to 24 divided by -3, because x will be a -3, right? So this will be y is equal to -8. Let me write smaller here. Y is equal to -8. Now let's see what happens when x is equal to -4. So this is 24 divided by -4, which will give you a -6. Perfect. Now let's do -8. When x is equal to -8, what is y equal to? Well, 24 divided by -8 gives you a -3. Okay? Now what happens when x is equal to -12? 24 divided by -12 will give me a -2. Okay, now that we have our negative value, let's go ahead and find our positive value. So we're going to use the same exact values for x, except we're just going to take the absolute value of these numbers here. So +3, 4, 8, and 12. Okay, well, when x is equal to 24, when x is equal to 3, I'm sorry, this will be 24 divided by 3, which will give me 8. Now when x is equal to 4, 24 divided by 4 will give me 6. Now this says when x is equal to 8, this will be 24 divided by 8, which will give me 3. At the same time, what happens when 12 is equal to x? Well, y is equal to 24 divided by 12. Y is equal to 2. Okay, perfect. So we have enough to actually form a graph here. So we need some room. So let's go ahead and erase this here so we can have some room for our graph. Okay. Don't forget, this is our actual variation function here. So let's see here. if we graph this, let's graph the coordinates -3, -8. So -3, -8. We're just going to estimate here a little bit. -4. So that's -3, -4 will be right here. -6 will be about right there. Then this will be -8. That's going to go all the way out over here. Then we're going to go down -3. That's going to be about right there. Then it says we're going to do -12 and 2. So that's going to go about right there. Okay. Now let's also see here. Let's make this line here a little bit longer. The x-axis line. Now let's see. Now we're going to grab +3 and +8. So +3, and then we're going to go up a +8. Okay. Now it says 4, so we're going to go 4 and then 6. Well, let's see, 4 and then 6, which will be about right there. Then let's go over 8 and then up 3. Well, that's right there. Then it says, let me make this, extend this x-axis a little bit. Then it says what? It says we're going to go to over 12. So we're going over 12. That's 8, so we're going to go over 12, which will be right here. And then we're going to go up 2. Perfect. What does this graph actually look like? Well, let's go ahead and sketch the graph here. Let's go ahead and try to connect these dots here and see what actually we get. Well, we get a funny shaped thing looking like this. Sorry, I can't draw it straight, but we get a funny shaped thing over here. And then at the same time, we get that same funny shaped thing over here. Well, what could this be? Because we have these funny shaped things on each side of my graph, and it looks like here that this is not going to touch this. This isn't touching this. Well, what is this? Because every time it gets close to it, when it gets close to touching it, it turns. Well, what is this? This is what we call a hyperbola. Okay, a hyperbola. Okay. We will talk about this a lot later on after we get out of rational functions and when we go into more of our conic sections. We'll talk about what a hyperbola is, okay? But this is the graph of the hyperbola. So just remember this graph here, okay? Let's erase that note, not so you don't get confused. Okay, what this actually is, this says that this graph in green is asymptotic. This graph in green is asymptotic to my x-axis. It's an asymptote. This in green is the asymptote. I'm sorry, my x-axis is the asymptote of this here function. It's an asymptote. It's never an asymptote. Basically says it's never going to touch that asymptote. My graph never touches its asymptote, so it's never going to touch this x-axis. This x-axis here, or this graph will never touch this x-axis. It'll get as close to 0 as possible, but it will never reach 0 itself. Okay, that's why we say this graph is asymptotic to my x-axis. Okay, it's asymptotic to my x-axis. Okay, so I really love talking about inverse functions because the graph looks so amazing and it reminds me much of a parabola because a hyperbola, because it is a hyperbola. Okay, well, let's go ahead and talk. Don't get this confused with hyperbole in English, but this is hyperbola. Okay, this is a conic section in algebra 2. Okay, so let's go ahead and do another example of inverse variation. Okay. Let's see here. Let me erase this. We can just about leave those values for our next equation here. We can just change the just erase the x's, of course. Okay, let's see here. So we're going to change that, and we'll change that. Okay, so we'll say y varies inversely as x and y is equal to 2 when x is equal to 6. Okay, well, let's go ahead and find this variation function here. Okay, give me one quick second here. Let me make sure that we're going to use the right points here. Okay, perfect. All right. Let's just go ahead and erase these. We'll just get some new x value points so we can just deal with some new numbers. Okay, so let's see here. If we want to write the inverse function, the inverse variation function when y is equal to 2 and x is equal to 6? Well, let's go ahead and do it. It'll be, since it's inversely, it varies inversely, it'll be y is equal to k over x. Okay? Now that it varies inversely, what we can actually do with this, we can actually say y is equal to 2. Of course, we're going to do some substitution in order to find our k value. We're doing substitution in order to find our k value. So 2 is equal to k, because we want to solve for k, divided by our x is 6. Okay, because when y is equal to 2, my x will be 6. Now let's just solve for k in this here equation by multiplying both sides by 6. Those 6's cancel, leaving me with 6 times 2 is equal to k. So this says k is equal to 12. So that means my inverse variation function would be y is equal to 12 over x, because we just substitute the k for the value that we have for k in for the actual k space, the k variable in this here function. Let me draw it going this way so you can into the actual k function here. Okay, perfect. So now that we have got the equation, which is y is equal to 12 over x, let's go ahead and find what my graphic will actually look like. And let's see if it actually turns out to look like the hyperbola that we just drew a minute ago. Well, let's see. Let's just get some x values here. Let's just take 2. Let's take 3, let's take 4, and let's take 6. And then for my negatives, we'll take a -2, a -3, a -4, and a -6. Well, when we have 2, we know 2, when x is equal to 2, so it's going to be 12 divided by 2, which will give me 6. Okay, then when x is equal to 3, this will be y is equal to 12 divided by 3, which will give me 4. Then when x is equal to 4, this would be y is equal to 12 divided by 4, which will give me 3. Then when x is equal to 6, this will be y is equal to 12 divided by 6, which will be y is equal to 2. Okay, now the same thing for these negative values here. When my x is equal to a -2, we say that 12 divided by -2, which will give me a -6. And then when x is equal to a -3, this will be 12 divided by -3, which will be a -4. And it's basically going to be the same values here, just different signs. So it's going to be a -3, and then this will be a -2 here, because you're basically just switching the sign because we switched the sign of the x value here, right? Okay, perfect. So let's go ahead and see what my graph looks like here. So to save space, we're going to just erase this over here, but keep our equation that we came up with, which is, our function which we came up with, which is y is equal to 12 divided by x. Well, let's see here. I want to get a little bit more spacious, exactly so we can, exactly so we can see how this graph here looks. Okay. So let's go ahead and plot these points. Let's plot the points 2, 6. So we'll go over 2 and up 6. We'll plot right there. Let's see, we'll go over 3. So we'll go over right about here. And then we'll go up 4. Let's see, and go up 4. So it'll be right about there. And it'll go over 4. So over 4. And we'll go up 3. Okay, that'll be right about there. Then we'll go over 6. Then we're going to go up 2. We'll just say 2 is right there. We'll set this to scale. Okay, we'll set this to scale as 2 being right here. Okay, or because that really does not look like 2 at all. It looks like 1 or 1.5. So let's go ahead and just take this graph up a little bit. So 2, 6, this will be 2. This will be 2, go over 2, go up 6. Let's just take 6 higher. Then 3, go over 3. Then it means 4 will be somewhere right here. And then let's do 4, 3, go over 4. Then go up 3, be right there. Then let's go over 6, and then let's go up 2. Okay, and we're right there. Perfect. Now let's go ahead and do this next one. Let's do the negative values. It says a -2. Let me get a different color. It says -2, so we're going to go over -2, and then we're going to go down to -6. Perfect, right there. Then it says a -3, we're going to go down to -4, so we're somewhere right there. Then it says we're going to go down and go over a -4, so we're going over -4, and then we're going to go down to -3, so we're somewhere right here. Then it says going to go over a -6, and then we're going to go down to -2, so we're somewhere right here. Now this actually, I'm going to have to redraw this because you can't see the curve here. I'm going to need to do this. So let's draw it a little bit better because it's hard doing it when you're not looking at an actual scale. So let's go over -2 and then go down to -6. Let's say that's right there. Then a -3. Then go down -4. And -2, let's see, -4, that'd be right there. And then let's do -4. -4, and then we're going to go down -3, that'd be right there. Then let's see -6, and then we're going to go down -2, that'd be right there. Perfect. Okay, now let's go ahead and sketch, try to connect these dots here, sketch my graph. Well, it looks like my graph looks like this over here on this side. Looks like that over there. And then this one over here looks like this. Okay, perfect. This does indeed look like my hyperbola that we drew last time. Now, I did tell you that this graph was asymptotic to this x-axis, but I did not tell you it's also asymptotic to this y. Because if you look at it here, you see it does not cross this y-axis, these y-axes, nor is it touching this x-axis. It's touching neither one of them. It's getting very close to it, like here, as you can see, very close, but never touches. So that means it's an asymptote of this graph. Okay, this is asymptotic. This graph here is asymptotic. So that means my x and y axis are its vertical and horizontal asymptotes. Okay, this x and y axis, let me say that again, this y and this x axis are my vertical and horizontal asymptotes. Okay. So this is the graph of this function, of this function here, y is equal to 12 divided by x, which I said is a hyperbola. And we're going to go ahead and stop this video, and we'll resume next video with some applications of inverse and direct variation, and then we'll go into talking about joint and combined variations.